Hello everyone and welcome back to the channel. We have talked extensively about the magic of caching, how it speeds up reads and saves your database from overload. But what happens when a popular cached item expires and suddenly thousands, even millions of requests for that very same item all hit your backend at the exact same time? This is a classic and potentially catastrophic problem known as cache stampede or the thundering herd problem. Today, we are going to break down what a cache stampede is, why it is so dangerous, and most importantly, the key strategies to protect your database from this overwhelming flood of requests. So first, what is cache stampede? It's a phenomenon that occurs when a highly popular cached item either expires simultaneously, like its time to live or runs out, for example, or it is explicitly invalidated, like and a large number of concurrent requests for that item arrive at the cache at precisely the same moment. So let's just trace trace the flow to understand how this problem works. So let's say that a popular item like a trending news article. Okay, let's say that we have a popular item like a trending news article, a product page, for example, for a flash sale, maybe, or a critical configuration setting being heavily accessed and is sitting in the cache. So we have a newsletter that it's heavily accessed and it's sitting in the cache. But suddenly, it's time to live. Ill. Suddenly, it's time to live expires, or it's manually invalidated. The cache no longer has it. So this newsletter is not in the cache. Now, thousands of concurrent user will go to our database now. A lot of requests will go to our database. Request for this same item that cache doesn't have. Every single one of these requests in occurs every single one of these requests after accusing a cache miss will crucially will go to the database. Crucially, because the item is popular and just expired, all of these requests simultaneously attempt to rebuild the cache by fetching the data from the backend database. This creates a massive surge of identical queries hitting your database, overwhelming it, even if it normally handles a high load. It's like thousands of thirsty animals suddenly rushing to the same watering hole. Okay, that's just. So let's say that you have your application here. Okay, and we have our database and we have the cache. Let's say that we have a famous product. Let's say that this is an e-commerce and we have a famous product that a lot of users like to query. Okay, so this product, let's call it X. This X product is invalidated from the cache or eliminated from the cache due to its time to live has expired. Okay, so it's the app will had a lot of requests from different users will trying to read this specific product X, and the product is not even there. It's not there because it's time to live, or maybe it was invalidated. It's not even there. So all of these requests will go in the same time to the database. All of them will go to the same time to the database, which will overwhelm the database. And after that, the database will send all these requests back with the same item to the app, and the app will update the cache multiple times. You see how many errors do we have here? It's a ton of errors. So okay, let's understand. It looks like we're duplicating everything, we overwhelming the database, but what is exactly the problem? Like, why this is too dangerous? Okay, so if you want to understand that, the danger of cache stampede is served because it's severe because It directly attacks your most vulnerable and resource-intensive components, which are your database and backend services. First, we have database overload. Thundering herd of identical queries can quickly exhaust your database connection pool, CPU, and I/O resources. This can lead to slow query execution, timeouts, and even database crashes. Number two, we have cascading failures. An overloaded database can cause your application servers to time out, leading to errors for users, increased retries, and potentially a full system meltdown. This is a classic example of how a seemingly simple cache expiration can bring down an entire distributed system. Also, we can have some sort of degraded in user experience. Like users experience massive delays, errors, and complete breakdowns of service, even if the underlying data is actually available in the database. Number four, resource inefficiency. You're wasting valuable database and application server resources on redundant work, as many identical queries are being processed concurrently to fetch the same piece of data. Okay, so we know it's pretty dangerous, so we will need to talk about some strategies to compact cache stampede. Like protecting your system from cache stampede requires a proactive strategies. One of them, it's like the mutex locks. Like when a cache miss occurs for a specific key, only one of the concurrent requests is allowed to proceed to the database to fetch the data and repopulate the cache. All other requests for the same key are temporarily blocked or wait for the first request to complete. This is often implemented using a distributed lock on the cache key. The pros of this one, it's highly effective in preventing redundant database queries. Only one request files to the backend. The problem with this one, it introduces a small amount of latency for waiting requests, requires a careful implementation for distributed locks, which can be complex and introduce their own failure models. Number two, proactive cache warming. Okay, so instead of waiting for items to expire and be requested, you actively refresh popular or critical cache entries before they expire. This can be done by background job that periodically fetches data or by using an asynchronous update mechanism. The pros of it, it prevents the cache from ever becoming cold for critical items. User always get fresh data from the cache. Cons of it requires identifying and predicting popular items, can consume backend resources for prefetching, not suitable for all data types or unpredictable access patterns. Number three, stale while revalidate. When a cached item expires, if a request comes in, the cache serves the stale or expired version of the data immediately to the user. Concurrently, in the background, a single process fetches the fresh data from the database and updates the cache. The pros of it eliminates user-facing latency during revalidation, prevents any requests from hitting the database during the revalidation window beyond the initial one, provides a continuous user experience. The cons of it, users might temporarily receive slightly stale data, requires application logic to handle serving stale data and background revalidation. Number four, randomized time to live. So instead of setting a fixed time to live, exactly 60 minutes or something like that, for all instances of cached items, you add a small random variance of the time to live. So an item might expire in 58 minutes, another in 62 minutes. The pros of this one, it spreads out the cache expiration events, preventing a large number of items from expiring at the exact same moment. This reduces the sharp peak of requests hitting the database. The cons of it, it only mitigates the problem, doesn't eliminate it. the stampede effect entirely. Doesn't eliminate the stampede effect. Actually requires a careful tuning for um, the randomized time to live. Okay, so cache stampede is a critical challenge in high traffic application, capable of turning a performance optimization into a system crashing event. But by implementing intelligent strategies like mutex locks, proactive warming, stale while revalidate, and randomized time to live, you can effectively tame the thundering herd. Understanding these defenses is crucial for building robust, scalable, and resilient systems that stand strong even under immense load. Don't let your cache turn into your database worst enemy. So yeah, that's it for this video, and see you